Okay, so we're asked to find the expected value of the number of nights potential customers will need. So an expected value is like how much we expect to get for an event on average if we kept doing it over and over. You know, if you, let's see, if you rolled a certain die again and again and again, you kept adding up the number of, you kept listing out the number that you got on that die. And then you divide by the number of times you rolled it, you'd be calculating the average, right? And that would be the expected value of the die. So same thing here. When you calculate expected value, if you're given probabilities, you're going to take the probability times the value plus the next probability times value. And you just keep going like that until you've done all the possible different outcomes for the event. So find the expected value of the number of nights potential customers will need. Let's see, it says that 10% of potential customers will choose the day plan, which does not include overall night accommodations. So here's the decimal form of the probability times the amount of nights. There's 0 nights with the day plan. And here's the decimal form of the probability for the next option. 20% would choose the overnight plan, which is 1 night. So that's the value, is 1. And then 70% will choose the weekend plan, which includes 2 nights. So 2 is the value on that one. So this is 0, this is 0.0, and this is 1.4. So we're expecting 1.6 nights per customer. If they have a ton of customers, they can use that to plan out how many rooms they need to have. Standard deviation, the number of nights per customer. So let me get that formula out. So I couldn't find a good picture online. I just drew it here. The standard deviation is just the square root of the variance. Okay, so whatever we calculate with this formula, we're going to take the square root. So the variance is found by taking each value squared and then calculating the expected value of it. So we got to go back up in this, in our workup here, and we're going to square each value of x. So 0.10, our value was 0, and that gets squared. And then we had 0.20 times 1, and then we're calculating the expected value when our values are squared. So the expected value when x is squared. So each of those numbers we put in, like 0, 1, and 2. Okay, so if we do that, first one's nice and easy because 0 squared is 0. Second one's also nice and easy. That's going to be 1 squared is 1, so it's 0.20. Now the third one, that's 2 squared times 0.7, that's 2.8. Oops. That means the expected value of x squared is 3. So we got 3 for this part of the formula. And now this part is going to be easy because we already have the expected value. There's a subtle difference in this notation, right? X is being squared, and then you calculate the expected value. Over here, you calculate the expected value of x, and then you square it. So we have the expected value of x. Now we just need to square it. So 1.6 squared, we subtract that from 3. 0.44. So our variance is 0.44. And since they asked for the standard deviation, we just need to take a square root of the variance. So to 2 decimal places, it looks like it's 0.669. And that's it.